then instead of the upper and lower, you have the right function and the left function. Is that right? Yes. So the area enclosed by the graph of f of y and g of y, two functions of y, from y equal to c to y equal to d, will be integral c to d, the right function minus the left function. The function on the right minus the function on the left. Okay, now let's have a look at that. Suppose this is a function f of y, and the red line is a function g of y. Look at the area enclosed by the graph of that. Now, these two functions meet at y equal to c and y equal to d. So what does the enclosed area gives you? The enclosed area is this, the area enclosed by f of y with g of y from y equal to c to y equal to d is integral c to d f of y minus g of y, the right function minus the left function. Well, let's practice this. Sketch the region bounded by f of y equal to y over square root of 16 minus y squared. Now remember, this can also be written as x equal to y over square root 16 minus y squared. Just the same way we write y equal to x over square root 16 minus x squared. Is that right? So you got f of y equal to this and g of y equal to 0. What is that? What is g of y equal to 0? G of y equal to 0 is the y-axis, or no, g of y equal to 0 is the x-axis. It's the x-axis, which is y equal to 0. So you need to find the area between f of y equal to y over square root 16 minus y squared and gy equal to 0. So your f of y is this, and that can, now we said f of y equal to y over 16 minus x squared is actually the same as x equal to y over 16 minus y squared. I just told you that earlier. In other words, f of x equal to 5x plus 2 is the same as y equal to 5x plus 2. In the same way, f of y equal to y over square root 16 minus y squared is the same as x equal to y over square root 16 minus y squared. Now the problem is, if I want you to graph this function on your calculator, the calculator doesn't have a y variable. It only has an x variable. So what we need to do is, in order to graph this, we need to convert it as a function of x. Then only we can graph it. Now how do you do that? You've got to solve this equation for y. So to graph this, we need to express y as a function of x for solving for y. Now how do you solve an equation like this for y? Alright, watch me how I do that. First of all, I square both sides. Make it easier to get the square root out of the way. Now what does that give you? It'll be x squared equal to y squared divided by 16 minus y squared. You see, if you want to solve for y, because y squared comes in two places, it's going to get multiplied by x squared. If you want to simplify this, it's going to create problems. So what I'm going to do is, I'm going to invert the left-hand side and the right-hand side and see what difference it makes. Look at this. 1 over the left-hand side equal to 1 over the right-hand side. 1 over x squared equal to 1 over the right-hand side means simply flip them over. 16 minus y squared over y squared. What is the advantage? The advantage is I can now split the right-hand side into two parts. 16 minus y squared over y squared is the same as 16 over y squared minus y squared over y squared. Look at that. Now, why did I say this is an advantage? Because y squared over y squared is 1. That means, whereas we had y squared in 2 places here, which made it difficult for us to solve for y, we are now reducing that y squared to a single place. We can now solve for y easily. So what is this equal to? We have 1 over x squared equal to 16 over y squared minus 1. We need to solve for y, means leave this term here and take that negative 1 to the left side. It'll give you 1 over x squared plus 1 equal to 16 over y squared, or we can write 16 over y squared equal to 1 over x squared plus 1, or 1 plus 1 over x squared. They're all the same. And now let's simplify this. 1 plus 1 over x squared is x squared plus 1 over x squared. And now what do? We can, well, what we can do is we can now solve for y squared. Is that right? If 16 over y squared is this quantity divided by x squared, then y squared equal to, cross multiply, 16 times x squared divided by x squared plus 1. So y squared equal to 16x squared divided by x squared plus 1. And therefore, what is y? Y equal to, there will be 2 values of y, plus or minus 4x over square root x plus 1. Now, since f of y is given as a positive quantity, we need only the positive value here. So, the positive value is y equal to 4x over x squared plus 1. In other words, the graph of this function is the same as the graph of the positive part of this function. So we will use the positive part to draw the graph. The graph of f of y equal to y over square root 16 minus y squared is actually the same as the graph of y equal to 4x over x squared plus 1. I hope you understood what actually happened. Well, this function is x equal to y over square root 16 minus y squared. But the calculator does not draw that graph. So what we did is we solved that for y and expressed the function as a function of x. Alright, let's draw the graph now. This is the graph of y equal to 4x over square root of x plus 1. Now, we need to find the area enclosed by the graph of this function, which is the same as this function, and then g of y equal to 0. G of y equal to 0 is the y-axis. Is that right? There you got it. This is g of y equal to 0. And the line y equal to 3. This is the line y equal to 3. So, look at the area that we need to find. We need to find the area enclosed by the graph of x equal to y over square root 16 minus y squared. Look at the way I read it. In place of f of y, I read it as x. X equal to y over square root 16 minus y squared. That is that graph. F of y equal to 0 means x equal to 0 and y equal to 0. Now that means, what are the boundaries? Now, what is the region bounded by f of y equal to y over square root 16 minus y squared? G of y equal to 0, that is the y-axis, and y equal to 3. This is the area we are looking for. It is the area enclosed by the graph of f of y with the y-axis from y equal to 0 to y equal to 3. That's right. So this is y equal to 0, and that's y equal to 3. That's the area that we're looking for. All right? So that will be integral 0 to 3 along the y-axis, right function minus the left function. The right function is our f of y. The left function is our g of y equal to 0. So that will be integral 0 to 3 of f of y, y over square root 16 minus y squared dy, minus g of y. I did not write that there because that g of y is 0. Alright, how do you integrate this? If you remember the integration by substitution skill that you developed in Calculus 1, the denominator under the square root you have 16 minus y squared. On the numerator you have y dy. Therefore, you can make an easy substitution that 16 minus y squared equal to u. So we make that substitution, 16 minus y squared equal to u. Now remember, the moment you make a substitution of a quantity, then we need to replace everything else in the integral based on that substitution. So if 16 minus y squared equal to u, what is then y dy in terms of u? Well, all we need to do is find the differential of both sides of the equation. Differential of 16 is 0. The differential of minus y squared is minus 2y dy. Remember that one? Equal to differential of u is du. So minus 2y dy equal to du. Now you need, if you forgot this, you need to go back and polish the skill of substitution. If 16 minus y squared equal to u, take the differential of both sides. Differential of 16 is 0. Differential of minus y squared is minus 2y dy equal to differential of u is du. Now, what this gives you is we can now solve for y dy. That is what we need to replace here. So y dy equal to negative du over 2. There you have. So when this quantity 16 minus y squared becomes u, then the quantity y dy becomes negative du over 2. We also need to deal with the limits. The limits 0 to 3 are given for this y. But because 16 minus y squared has been now replaced by u, we need to replace these limits in terms of u. For example, when y equal to 0, that is this limit, when y equal to 0, u equal to 16. Therefore, in our new integral, when you replace this quantity by u, this limit y equal to 0 become u equal to 16. Let's do that. So use the substitution to rewrite the limits. When y equal to 0, u equal to 16. How about this? When y equal to 3, put y equal to 3 there. It'll be 16 minus 9 equal to u, or when y equal to 3, u equal to 7. Therefore, when you replace 16 minus y squared by this u, and y dy by negative du over 2, the lower limit y equal to 0 becomes u equal to 16, and the upper limit y equal to 3 becomes u equal to 7. So what is the new integral? Integral 0 to 3 y over square root 16 minus y squared dy now becomes integral 16 to 7 of, look at this, negative 1 over 2 square root u du. Did you understand this? If you recall, our y dy is negative du over 2. There you got negative du